Hello students, welcome to today's session of chemistry. As you know, we have finished 7th lesson of your syllabus, that is modern periodic table. Modern periodic table is the basis of chemistry, we can say, because periodic table is nothing but the classification of elements in various groups as well as periods. Also, the arrangement can be seen in another way in the form of blocks. So, arrangement based on blocks is also there. There are 4 different blocks: S block, P block, D block, and F block. As well as there are 18 columns, we call them groups. 7 rows, we call them periods. And the base of all this classification is modern periodic law, which tells us that the arrangement of elements in the periodic table is based on atomic number, or the elements are arranged in the increasing order of their atomic number, and the arrangement or the law says that the physical and chemical properties of the elements are the periodic function of their atomic number. So, atomic number is the base on which the total arrangement of periodic table is based. We have seen in detail all about this arrangement, the characteristics of all the elements, why they are placed there, and how the properties change along a period down the group, the various physical properties, chemical properties, elemental properties, and their change according to periods and groups we have seen in detail in periodic table. Now, in connection to that, I'm going to start with the 8th lesson of your syllabus, and the name is Elements of Group 1 and Group 2. So, where are these groups in periodic table? As the name suggests, these are placed to the extreme left because they are Group 1 and Group 2 elements. So, Group 1 and Group 2 elements are there to the extreme left of the periodic table. That means they are here. This is Group 1, this is Group 2. So, we are going to see in detail about the elements of Group 1 and Group 2 in this lesson. Now, as you all know, due to COVID-19 situation, much of the syllabus is deleted from your syllabus for this year. So, this lesson also has some part which is deleted from this year, which is that now the start of the lesson is from hydrogen, because as we are going to see about elements of group 1 and group 2, the first element of the periodic table also of the group 1 is hydrogen, and there is detailed study of hydrogen in your lesson. If you refer your textbook, you will see that. So, the detailed study of hydrogen, everything about hydrogen, that part is deleted for this year. So, I'm not going to take that. So, the remaining part of the syllabus which is included or which is there for this year, that we are going to learn now. So, let us begin with 8th lesson of your syllabus, that is elements of group 1 and group 2. So, these are the two groups. Actually, they are placed to the extreme left, but I have taken here on the right side of the slide just for the reference. Those should be in front of your eyes always, because you have to remember the names as well as the elements which are there in the group 1 and group 2. So, we will begin with Elements of group 1 and group 2 belong to the S block of the modern periodic table. Why they are called S block elements? We have seen the definition as well. If we write the electronic configuration of any of the element from group 1 and group 2, you will see that the last electron or the valence electron enters S subshell. That's why these are called S block elements. So group 1 and group 2 together form S block of the periodic table. And out of those elements, hydrogen is the first element in the periodic table. It appears at the top of the group 1 of the alkali metals. Now, out of these two groups, first group, group 1, those elements are called alkali metals, and group 2 elements are called alkaline earth metals. We will see why they are called like that later. Just now, hydrogen. About hydrogen, if we see, it is there in the first position of the group 1, that means of alkali metals, but it does not show the properties similar to alkali metals. It differs from alkali metals in number of respects or aspects, we can say. Therefore, study of hydrogen is done separately. And as I told you, the study of hydrogen that is deleted for this year. So, hydrogen actually, according to its electronic configuration, which is 1s1, it should be there in the alkali metals as per rule. But the properties, if we say, see, those are different. Some peoples or some scientists, they say that it should be placed in the 17th group as well, because it requires only one electron to complete its octet. We can say duplet, because first inert gas is helium, which has atomic number 2. So it requires only one electron. So it should be there in the 17th group. But it does not resemble, or it does not show any property similar to that of halogens as well. Hence, nowadays, hydrogen is placed at the center in the first period only. But at the center, it does not belong to alkali metals or that of halogens. But the study of hydrogen has been deleted, hence I will not go in detail. Now, the elements of group 1 and group 2 are placed on the left of the periodic table if the position is asked, and why, as I told you, their last electron enters into NS subshell. They are the members of S block then. Which are the elements then? You have to remember the names as well. Try to remember the names as well as their symbols along with their atomic number. The first member, hydrogen, the atomic number 1, lithium 3, sodium 11, potassium 19, rubidium 37, cesium 55, and francium 87. So these are the elements of first group, that is alkali metals, and alkali metals are there at the extreme left of the periodic table. These elements, except hydrogen, are collectively called alkali metals. Two elements of group 1, the sodium as well as potassium, are the 6th and 7th most abundant elements in earth crust. Now, if you see the occurrence, where they occur in nature, so sodium and potassium are most abundant. Sodium 6th abundant, while potassium is 7th most abundant element in earth crust. But out of these elements, last element, that is francium, it is, as it is radioactive, it has very short half-life period, so it doesn't occur appreciably in nature, and we can say it doesn't exist for longer time. Now, about group 2. So here it is a group 2. Group 2 elements, which are those? With beryllium, atomic number 4, magnesium 12, calcium 20 atomic number, strontium with 38 atomic number, barium, and last one is radium. So it starts with beryllium and ends at radium. Do you know one interesting thing about these elements? They are called alkaline earth metals because they form alkali on treatment with water and they occur as minerals in rocks. Hence, they are called as alkaline earth metals. Out of these elements, the magnesium and calcium are abundant again. They found abundantly in earth crust, but again the last element, that is radium, which is again radioactive. Hence the radioactive elements does not exist for longer time in, on the in the atmosphere. And do you know radium, that one is discovered by Madame Curie. Do you know one more element she has discovered that is also radioactive? So, second element she discovered is polonium. She gave that name because she belonged to the nation Poland. So, she dedicated her research to her nation and gave that element name as polonium, and the other element she found is radium. So these two radioactive elements she got, and she got Nobel Prize for that. Now, next thing we are going to see today is electronic configuration of elements of group 1 and group 2. Now you know how to write electronic configuration because I think fourth that the structure of atom, that lesson Barsarab madam she has taken. So if you don't understand, then go through that lesson again and just learn how to write electronic configuration. I also in the last lesson during that lesson I also have taught you about the writing of electronic configuration that requires three different rules which are the basis of electronic configuration. Those try to understand those. Just refer your textbook, refer the videos sent by Ashwini ma'am, and then you will understand in better way. So electronic configuration that requires Hund's rule, Pauli's exclusion principle, above principle, together they are applied to write the electronic configuration. Okay. Now, in exam also, this is basic question. They give you atomic number, name of the element, and ask you to write the electronic configuration. And for that, you must know how to write electronic configuration. Now, electronic configuration of both the groups we are going to see. The general outer electronic configuration of first group. General. All the elements of group 1 show NS1 as the general electronic configuration. What is N here? N is first quantum number, principal quantum number, and S is S subshell with one electron. N is the valence shell, in which that is nth shell is the ultimate shell, of which S subshell with one electron is the general outer electronic configuration of first group, alkali metals. Alkaline earth metal, they have only one electron extra, and hence their electronic configuration is Ns2. Remember this, general outer electronic configuration. Now, the loosely held s electrons in valence shell of these elements can be easily removed to form metal ions. Hence, these elements are never found in free state in nature. Do you understand by this? Now, these elements are very reactive elements, we can say. Very reactive elements. Why? Because these elements, if you see at the general outer electronic configuration, they have only one electron in the outermost shell. These elements are placed to the extreme left of the periodic table. So, they have largest atomic size in their respective period. We have seen these properties and trends during 7th lesson. Now, they have largest atomic size in their respective periods. They have lowest ionization enthalpies. That means low energy is required to remove outermost electrons, and hence they easily donate their electrons. And when they donate electron, they form unipositive ions. That means cations are formed, metal cations are formed with 1 plus charge, because only one electron, which is in the outermost shell, is donated so as to get stability. Hence, they will get the noble gas configuration or inert gas configuration and will be stable. Hence, these electrons, these elements, they never occur in free state in nature. All the metals of the first group, they always occur in the combined state. That means sodium will form salt like NaCl, KCl, and they occur in seawater, the largest proportion. All these elements, they are abundant in nature but not in free state, always in the compound form. Now there are two tables. Those will show you the electronic configuration of the elements of group 1, that is alkali metals, and group 2, alkaline earth metals. All the electronic configuration I have shown in a table, but you have to write those tables at home, which is the homework for today. Now this table, this is the electronic configuration of group 1 element, that is alkali metals. If you see condensed electronic configuration here, and here the detailed electronic configuration is given. Now hydrogen is 1s1, atomic number 1. Lithium atomic number 3 will be helium in square bracket 2s1, or we can say 1s2 2s1. Now this condensed for configuration, here the nearest inert gas is written in the square bracket, and then remaining electronic configuration is written in front of it. Now neon with atomic number 10 is 1s2 2s2 2p6. So neon in the square bracket means up to 10 electrons, the electronic configuration is written. What is remaining is only 1 electron, and that will go in 3s subshell. Hence 1s2 2s2 2p6 3s1, or neon in the square bracket 3s1 will be the electronic configuration of sodium. Anyone is okay. You can write anyone. Potassium with 19, argon in square bracket because argon has atomic number 18, and the remaining electron will go to 4s1. Or in detail we can say 1s2 2s2 2p6 3s2 3p6 and then 4s1. After 4s is complete, then 3d will start filling. So that is according to above principle. Rubidium with krypton 5s1, cesium xenon 6n1, francium radon 7s1. Or in detail it is given like this. For example, cesium with atomic number 55 will be 1s2 2s2 2p6, 3s2 3p6, 4s2 3d10 4p6, 5s2 4d10 5p6 6s1. So what is common here? In the last shell, the digit, that number gives us the quantum number. It is principal quantum number. That tells us the number of shell in which the electron goes. So last shell, we can say nth shell is the ultimate shell. So ns1, that means last is 1, last is 2, 3, 4. So in the last shell, there is only 1 electron. Hence, general outer electronic configuration is ns1. Understood? Now, what about alkaline earth metals? So this table shows you the electronic configuration of alkaline earth metals or group 2. So here, if you see, there is the outer electronic configuration is ns2. So last shell 2, 3, 4, 5, 6. Last shell has s subshell with 2 electrons. Or here we say final nth shell is ultimate shell. So the most, or we can say the last shell is here with 2 electrons. So the general outer electronic configuration of alkaline earth metal is ns2. So B4, helium in the square bracket 2s2, 1s2 2s2. 14 magnesium, 1s2, 2s2, 2p6, 3s2. So up to 2p6, it is neon, 10, so 3s2. Argon, that means 1s2, 2s2, 2p6, 3s2, 3p6 is argon with 18 atomic number, and 4s, the last shell, the biggest number, that will be ultimate shell. If you see the number, principal quantum number, if it is the last shell, then the number is the biggest one, nth shell, ultimate shell. So strontium, krypton 5s2, xenon 6s2, radon in square bracket with 7s2. So this is general and the detail as well as condensed electronic configuration of both the groups. You can write this as assignment. So what will be the assignment today? Just write down the electronic configuration of all the alkali metals as well as alkaline earth metals. Those are given on the page number 113. You can draw that table also. Understood? Thank you.